Alright, as you can see, we got some nice standing flames, a little bit of oscillation from the vibrations in the hose. Let's throw some sound in there and see what happens. Let's start with a 449 hertz frequency. As you can see, this sets up a standing wave, and we can see, well, the emerging sine curve that represents sound. What happens here is we're having the sound compressing here and not compressing here. The lower pressure here allows more gas to escape into the atmosphere, shaping the sound curve. Now, if we change the frequency, we can see each time we set up a standing wave, we get that sine curve. Higher the frequency, the more waves. Now let's throw some music at this. How about some Dave Ruben? Now we have real life sound visualization with 5. Isn't terribly energetic, so let's try something a little more energetic.
To begin, Ruben's tube was invented by German physicist Heinrich Ruben in 1905 as an experimental method of visually representing the presence of sound waves. This experiment requires a specific procedure in order to conduct it safely and effectively. This contraption consists of a long metal tube with holes drilled evenly apart along one side of it. The tube is then filled with propane by hooking up a propane tank to one end of the tube. The other end of the tube will have some sort of seal, trapping the gas inside. This end of the tube will also have a speaker attached to it. Then, the person conducting the experiment will light the propane that is exiting the holes along the side of the tube with a match or a lighter. Using the speaker, they will play a sound or a song. The various frequencies and the changes between them will be evidently represented by the Rubens tube. The sound particles move constantly throughout the tube as they are part of mechanical waves. The changes in heights of flames and their patterns is simply based on the continuous change in pressures along the inside of the tube. There is constant movement between the sound waves and gas as they continue to transfer in and out of regions with low and high pressures. The tall flames are evidence of a region with a higher concentration of pressure, as more of that propane is being pushed into the atmosphere, creating larger flames within the standing wave, and the opposite for regions along the tube with a lower concentration of pressure. Ruben's tube creates nodes and antinodes since all waves consist of these characteristics. Nodes are the sections of wave that have no displacement due to the destructive interference between waves, where the waves are completely out of sync with each other. Antinodes represent constructive interference between waves as the lines of each wave are in sync with each other, peaking at the same areas along the wave. The changing sound frequencies adjust the visual patterns in the flames until the speaker is turned off. Because each end is closed, the waves bounce constantly between each end of the tube. Represented by this figure, it is evident that these two waves are not in sequence as they peak at different locations, which is a prime example of destructive interference that creates nodes throughout the standing waves. This figure displays two waves that are in sequence, sharing the frequencies that overlap each other, which creates constructive interference resulting in antinodes along the standing wave. The Rubens tube is rarely seen today as its primary purpose is to showcase the relationship between sound frequencies and the different pressures along the journey of these sound waves. Since it is an older discovery, other scientists have helped advance other experiments that represent the same correlation but require less preparation and are much safer. Specifically, the oscilloscope has pretty much replaced the Rubens tube for experimentation. Nowadays, the Rubens tube is considered to be the old oscilloscope. However, it still may be used the odd time to demonstrate acoustics in an educational setting. Since Rubens tube is a visual representation of the movement of sound waves, they have also been used for entertainment purposes. Whether it's a different variation from a tube, the concept of Rubens tube has been seen at certain band concerts. This creates a more enjoyable environment for the audience. For instance, the production of fire at a rock concert can amplify the crowd's energy as a visual demonstration of flames dancing along to the music as well.